If during the design process you cannot find a required component in the FluidDesk BIM libraries and it is essential for your project, here is how you can quickly and easily add the missing element. For this purpose, we will use the Custom Element function. This allows the added component to appear in the bill of materials and be exported to the IFC format, just like all other project elements, which is crucial in the BIM coordination process. To minimize your workload, it is advisable to first check whether the desired component is available in DWG or RFA format. In this example, we will show how to use and adapt for our design needs a manufacturer's component available in RFA format. In our project, we need a DV-type fan from Rosenberg, size 500 6D6DF, which is not available in the VentPack libraries. We will locate the corresponding RFA family on the manufacturer's website and load it into Revit. Then we select the required variant of the DV fan from the imported family and place it in the model. It's worth noting that choosing the correct variant is not always straightforward and requires a good understanding of the product type and the naming conventions for variants and accessories. The next steps will ensure optimal export of this component. Switch to the 3D view, set the view scale to 1:1, and select Realistic Style with edges displayed and anti-aliasing enabled. Set the detail level to Fine. Next, go to the menu and select File, then Export and CAD format. Choose the ACS-SAT format. This is our recommended option, and proceed with the export. Specify the file name and destination folder for the exported file. Now, switch to FluidDesk BIM. Click the Application button with the FluidDesk logo in the top left corner, choose Import ACS-SAT, and select the previously saved file. After importing the file, go to the FLM View tab and choose the 3D Smoothed View. Now, proceed to the Custom Element function, available in VentPack. Once the function is activated, select the object you want to define as a custom element. The program will prompt you to specify a base point. This should be defined at the start of the process. It is a key reference point that determines where the element will be placed in the drawing space. Next, a window will appear for modifying the element's properties. Here, you need to specify the element type, name, and manufacturer. In the middle section of the window, it is useful to enter key characteristics describing the component. The next step is to define the connector. For the DV fan, the easiest way to do this is using the auxiliary cross-section function. This model of the fan uses a circular cross-section duct connection, for which we must define the diameter and connection point. This requires indicating 2 points that define the duct diameter and direction of the system's continuation. After creating the connector, assign it a name and select its type from the predefined dictionary. In our case, this will be round male duct. Then specify the connector's diameter. Upon completing this step, you will see the characteristic connection arrows, indicating the newly defined available connection point with a nominal diameter of 400. From this point, you can begin drawing the rest of the ventilation duct system. Once finished, use the numbering and dimensioning function to insert an information table, then use the auxiliary section button again to return to the main floor plan view. The custom element will also appear in the bill of materials, which can be exported to XLS, LML, or TXT formats. To verify whether the custom library element was defined correctly, select the installation section with the DV fan and enter the MKEIFC command. The selected components will be exported to the IFC format. Name the file and choose the save location. You can then open the exported IFC file in any IFC viewer to check the export results.